Hey guys, in today's video I'll take you through some of the basic concepts in ratio, variation and proportion. First let's focus on ratio. Ratio, as you know, is a concept used to compare two comparable quantities. For example, if I say 2:3 is the ratio of salaries of two people, A and B, then what does it mean? The only thing we can say is that their salaries are related some other way, but not exactly what their salaries are. For example, if you know one of their salaries as say 200, the other will be 300. In the same way, if A has a salary of 1000, that means B's salary will be 1500. Or you can say if A has a salary of 20,000, B will have a salary of 30,000. This is all you can infer from the ratio concept. You don't get the correct position or the correct value of the salaries. Ratio gives you a comparative position. Now there is something you can observe here. Now look at this. If you look at their salaries, 200 is what? 2 into 100. And in that case, B salary will be 3 into 100. Here if you look at A salary is 2 into 500. Then B salary for that value will be 3 into 500. In the same way here 2 into 10,000. Here it is 3 into 10,000. Or A and B have their salaries related to each other through a constant multiple. Or in general, you can write the salaries of A and B as 2K and BK, where K is what? We don't know. Now in this case, I have compared two comparable quantities. You can do comparison for even more than that. You can have three quantities or even more than that for comparison. Now, as you can see, K can be any number. Supposing you know something else from the data, like there is an additional information in the problem saying that total salaries of A and B, let it be equal to say 20,000. Supposing apart from their salaries being in this ratio 2:3, if you are provided with this information also in the problem, in that case you will be able to correctly fix the value of K. That is the general nature of problems in ratio. There will be a ratio, and apart from that there will be some other information in the problem which will help us to fix that multiple. See, use this condition here. Now total salary in terms of K will be 2K plus 3K. This is the total salary of A and B, and that's given to be 20,000. This implies what? 5K equal to 20,000. That implies K is equal to 20,000 by 5, which is 4,000. Now we got K fixed as 4,000. If you know what K is, automatically A's salary will be 2K, and that's equal to 2 into 4,000, which is 8,000. Similarly, you can find out salary of B as 3K, 3 into. Let's look at the next segment in this topic called proportion. Proportion, the word proportion, as you know, means what? Generally, it means share or part of something, a good proportion of something. When you say, that's the meaning. But in maths, In maths, proportion means equality of two ratios. For example, take two people like we did before, A and B. Let A is to B be the ratio of these two people's salaries. Similarly, X is to Y denotes ratio of their experiences in number of years. So there are two ratios here. These two ratios may or may not be equal. In case these two ratios happen to be equal, which means then as you can see there are four quantities here, A, B, X, Y. These four quantities are said to be in proportion. So given two ratios, they may or may not be equal. If they happen to be equal, as I have shown here, then we say these four quantities are in proportion. So this is the meaning of proportion in maths. And I have considered two ratios. This can be extended to even three or more ratios. So basically proportion in maths means equality of two or more ratios. There are a couple of results in proportion which are very useful in tackling problems. Let me list them one by one. This is the first result. That means if A by B equal to C by D, then A plus B by A minus B equal to C plus D by C minus D. The reverse is also true. Given this result, you can arrive at this result. Not going into the details of the derivation of these results, because normally in competitive exams, you're not deriving any result or you're not looking at the proof of any theorem. Instead, we should know how to correctly apply these results in tackling problems. So I'm leaving it there. Now the second result is, this is the second result. Basically, you're looking at a fraction in which the numerator is less than the denominator, and if you add the same number, that number being added is a positive number. Whatever be the number, if you add to the numerator and denominator the same number, the resulting fraction you get will always be greater than the original fraction you had. I will illustrate this result with a numerical case. For example, take 1 by 2. As you can see, A is this, B is this. 1 is less than 2. Now what I am going to do is, I am adding the same number to the numerator and denominator. Let the number, let it be say 2. Any number greater than 0 is good enough. So what do you get? 3 by 4. And now you compare these two. Which is bigger? This is bigger. And 3 by 4 you got by adding the same number 1 to the numerator and denominator of 1 by 2. See, this is in place of this, this is in place of this. This is what I meant by this result. Now the next result is similar to this. Same result. Here you're looking at a fraction with the numerator being bigger and you're adding the same number. And the resulting fraction will always be less than the original fraction you had taken. Again, I'll show you a numerical example to illustrate this point. See, I've taken 7 by 5. As you can see, 7 is bigger than 5. Like, numerator bigger than the denominator. And the number being added is 3. 3 is a positive number. And what do you get here? 10 by 8, which is 5 by 4. Now compare these two. Obviously, 5 by 4. Yeah, this is the implication of this result when applied to a fraction whose numerator is bigger than the denominator. There is one more result. I'll write it down first. What is this? I've taken n ratios or n fractions being equal. That's the first part of the result. So given n ratios, each of them is equal to another ratio you can obtain by, see, I have formed another ratio. How did I form? I have collected all the numerators of the fractions. Then for the denominator, I collected all the denominators. Then you can put either plus sign or minus sign. If you're putting plus in the numerator, use the same thing for the denominator, and that will be equal to this. Or here I have chosen all the numerators. In fact, you can choose as many numerators and as many denominators as you want. Let me choose two of them and let me put plus here. Okay, minus one, so I put no problem. That will be equal to this. Here I have taken two of them and that will be equal to, again, let me choose three of them, any three. You don't have to choose the first three. You can collect any three of them from among the n possible values. Okay, let me choose the first, just for convenience. See, I have used a plus sign. Then use plus sign in the denominator also. This is what I mean. You can choose four of them, you can choose all of them, you can choose five of them. If you're putting, for example, if you're putting minus sign, taking the first and, let me choose for a different case, let me choose the first and the last, and then let me choose minus. Okay, like that you can form many combinations and they all will be equal to this. Now, this may look a bit complicated when you look at the variables. I'll use some numerical numbers to help you understand this result better. Now, let me write this one. The result I started with 1 by 3. You can write it as 10 by 30. Are they equal? They are equal. Now you can write, if you want it, as 5 by 50. Or you can write it as 100 by 300. See, all of them are equal. This is what I have written here, nothing more. Now, okay, instead of n, I've chosen 4 ratios. Now, you can combine any 2 of them, any 3 of them, or all of them. Let me choose, like the last case, let me choose 1 and 100. Then use same denominators. I'm putting minus sign. You can put plus sign if you want, whatever. If you're putting one sign here, use the same here. Now you simplify this. What do you get? Minus 99 by minus 297. Minus gone. 99 will go exactly 3 times here. So what do you observe? On simplification, it reduces to 1 by 3. That means you can write, 100 by 3 minus 300. Because this on simplification is 1 by 3 and that is this. Everything is 1 by 3. This is the gist of this result I have given here. This result is very useful in tackling some complicated problems. You can shorten the steps if you use this result in that problem. There is one more concept I had mentioned right at the beginning of this session called variation. This point, this concept I will discuss in my next video because it needs an in-depth analysis. It requires a lot of explanation. So I'll take it up exclusively in some other video or rather in the next video. If there is any particular point which you're still unable to follow in all the results I showed you or the basic concepts, you may raise these questions in the comment section. I will address it there. See you guys in my next video where I will help you with some smart solutions to tricky problems based on these concepts I've already shown to you. Bye till then.